Hello, in this video we are going to discuss about discrete structures and theory of logic. The syllabus for this course is set theory, functions, natural numbers in Unit 1. In Unit 2 we have algebraic structures. In Unit 3 we have lattices. Unit 4 we have propositional logic. Unit 4 also we have predicate logic. Unit 5 we have trees, graphs and combinatorics. From all these units you can expect long questions from the underlying topic in red colors like operations and relations, operation and functions, mathematical inductions, groups, Lagrange theorem, normal subgroups, rings and fields, then axioms and theorems in Boolean algebra, also from lattices, tautology and theoretic inferences, quantifiers, and from graphs you can take questions like Eulerian and Hamiltonian paths. Then we have recurrence relation and generative function, and there are different methods of solving recurrences. From these underlying topics, you can expect long questions in your examination. So we will start with Unit 1, which consists of set theory, functions, and natural numbers. So whenever you are trying to read any unit, you first think that there are certain terms and terminology which anyone should remember so that it will be easy for anybody to understand the topic well and solve the problems easily. So the basic idea for understanding any topic or any chapter is lies on 4 different letters. First one is D, second one is R, then we have P and we have O. So D for definition, R for representation, P for types, and O for operations. So in this slide, we will discuss about how to understand sets very easily, or what are the topics anyone should cover for sets. First of all, we should know what is the definition of a set, how to represent the set, what are the types of sets, then what are the operations allowed on sets. So a set is an unordered collection of distinct objects called elements or members of the set. So there are certain terms here which are important. One is a collection, and again it's an unordered collection, and then distinct objects here. Then unordered means I can write the elements in any order. First element, second element, third element, fourth element, like this. Or we can say, we can change the position of the elements, then the set will not change. So that's why it is an unordered collection. Then what is the representation? How to represent the set? There are 3 different methods to represent the set. First one is roster or tabular form. In roster or tabular form, we write all the elements, we then call it as separated by comma. If there are a finite number of elements, then we can write all the elements. And if there is infinite number of elements, then we can write a triple dot to show that this process, this numbers of these elements will continue up in. Then we have set builder or rule method. There are two different methods. One is roster method, then we have set builder or rule method, where the set can be written like this. Within curly bracket, we write the element such that this property is satisfied. That is, x such that Px is any property of x. Then we have another graphical representation of a set, which we say Venn diagram. Any closed figure can be considered as a Venn diagram. Like here, I consider a set and which is represented within a closed diagram, closed figure. Then we have types of sets. How many types of sets are there? One is empty set or null set. We have singleton set. We have universal set. We have finite set. We have infinite set. So when we say finite, if the number of elements in a set are finite, then it's a finite set. Otherwise, it is an infinite set. Then in the types of sets, we have separated into two categories. One is elementary types, other is derived types. So elementary types means these are the basic definitions. From these elementary types of sets, we are considering a derived type of set that is called superset, a bigger set of a given set. Then we have a subset, a part of the given set. Then we have a power set, one method which we can create new sets, that is called power set. Also, another set called derived set, that's also known as multi-set. If number of elements is repeated in a set, then the set is known as multi-set. Normally, in a set, we assume that all the elements are distinct. But if the elements are repeated, then that particular set is a special type of set, which we say multi-set. That we will discuss in detail with example later. But initially, we will think about an overview of this unit, what we are going to study in detail. Then we have operations on sets. One is union of two sets, intersection of two sets, difference of sets, complement of a set, that is being denoted as a bar or a complement. Another operations on sets are Cartesian product of two sets. So these are some operations which we say elementary operations. Then using these symbols, either union or intersection or complement, we create some new symbols. Those are known as the derived operations. One of the derived operations is symmetric difference. That is, asymmetric B, a triangle B is equals to A minus B union B minus A. So this is the overview of the topic set. So whenever we are going to discuss about set, we should understand these things in detail, every terminology in detail. So we'll see some examples, but before that, for this unit, we'll discuss all other part in detail or all other part in this particular fashion. So this is what we call the mind map of each topic and subtopic. Once you create the mind map, it will be easier for you to solve the problems of each unit. So for sets, this will be the mind map you can have. Then we will discuss the relation. For relation, again, we have definition, representation, types, and operations. What is a relation? A relation R from A to B is a subset of A cross B. A relation R on A, if you define a relation on A, This is nothing but a subset of a classifier. Then what do you mean by domain of a relation? What do you mean by range? When we say domain of a relation, we'll talk about the first component of the ordered pair, and when we say range of the relation, we'll consider the second component of the ordered pair. So when we talk about the Cartesian product is nothing but the set of several ordered pairs, one element from set A, other element from set B. So we can define a relation either. So how can we represent the relation? We can represent the relation again using the same set representation like roster or tabular form, set builder form. Either we can have a graphical representation or we have matrix representation. Then we have types of sets like one types of relations like one relation, one many relation, many one relation, many relations, reflexive relation, irreflexive relation, symmetric, asymmetric, antisymmetric, and transitive. Then we have identity relation, binary relation, and NR relation. So these are all elementary types. Also, from these elementary types, we can have some derived types of relation. One is equivalence relation, partially ordered relation, totally ordered relation. That means when we have a relation which is reflexive, symmetric, and transitive, that's an equivalence relation. Similarly, a relation is partially ordered if it is a reflexive, antisymmetric. So these are all derived relations. Then we have different operations allowed on relation. One is inverse operation, other is union operation, intersection operation, and composition operation. That means composition of function, intersection of intersection composition of relation, intersection of relations, two relations, union of two relations, and inverse of a relation. These are all elementary operations allowed on a relation. Then once we have elementary operation, we can have derived operations on relation, that is known as the closure of a relation. Either we can find reflexive closure of a relation, symmetric closure of a relation, and transitive closure of a relation. Also, we will discuss some special types of relation, but this is the broad overview of the relations. First of all, we think about definition, then representation, then types, then operation. And we have function. In function, again the same concept like definition, representation, types, and operation. When we define a function, what we say, a relation R from A to B is said to be a function if every element of set A has a unique image in set B. So that we will discuss, every topic we will discuss in detail by considering several examples. But first of all, we should know definition, representation, types, and operations. So again, in the presentation, we can consider roster, a tabular form, set builder, a rule method. Then we have graphical representation like arrow method or curve method to represent the function. When we discuss function, we should aware of this terminology like domain of a function, codomain of a function, range of a function, what do you mean by image of a function, pre-image of a function, like that. We have different types of into function, identity function, one function, onto function, that is also known as injective and surjective function, one and onto both. If it is then that is known as a bijective function, then we have real functions. Again, real functions are divided into two categories, algebraic function and transcendental function. So algebraic function, again, we have constant function, rational function, irrational function. In transcendental, we have trigonometric functions, inverse function, inverse trigonometric function, exponential function, and logarithmic function. And we have special functions like differentialing, then we have characteristics function. Then we define something called recursively defined function. And in the recursively defined function, we have like factorial function, Ackermann function. When a function call itself, we call the recursive function, and these are two examples of recursive function. Then we have operations and functions. One is inverse operation, composition of functions. Like inverse function is denoted as F inverse, and compositions like F composition G or G of F of or GOF or F composition F, something like this. If F and G are two functions, then the composition can be symbolized like this. And different operations like addition, subtraction, multiplication, division, all are allowed for real function. If you have a real function, then we allow this kind of operations. This is the basic mind map of the function which every time we should aware of and we should remember. Then the next part is natural numbers, and in natural number series, natural number, we have definition, what is a set of natural number, how to represent, we can represent the set in form of a set natural number, or also we can represent in form of a number line. Then we have different types of natural number like even number, odd number, prime number, perfect number. These are all different types of numbers, natural numbers. Then these are the two operations allowed on plus, that is plus and into on the set of natural numbers. Then the next topic we are going to include, which will be related to the natural number, that is mathematical induction. This is a type of proof, or there are some problems which can be solved using mathematical induction. There are various variants of induction. There are various variants of induction which solve several types of problems. One is series problem using method of induction, divisibility problem by method of induction, inequality problem by method of induction. Then we have non-zero base cases. Non-zero base cases means the problem will satisfy, or in the problem we have a condition to prove the statement is true for n maybe greater than 2 or greater than 3 or greater than equals to 5, something like this. That means whenever we have a non-zero base case, the induction we are not starting from n is equal to 0 or 1. We can start from any other natural number, like n can be started from 2 or 3, like that. Then those are known as non-zero base. So method of induction can be solved using non-zero base cases. Then we have different proof methods also, that is proof by counterexample and proof by contradiction. So this is the mind map of UNIT-1, that is natural number, function, relation, and set. Okay, so these are the things anyone should remember to understand the problems in detail. Okay, so for all other units, for other units also, I am going to prepare the video, and I'm also going to discuss in my next video. Thank you.